Hello, welcome to distributive property area, or distributive property with area models. So let's go ahead. Our learning objective for today is to be able to use the area model to demonstrate the distributive property. Just a reminder of what distributive property problems typically look like. It's where you have something happening inside the parentheses. So for example, 7 plus 3. And then outside the parentheses it's being multiplied by another number. So looking at the examples at the top, we have a rectangle with a side length of 4 and a height of 5x. So if I was thinking about what this looks like in terms of the distributive property, I would essentially be doing 5x times 4. Now, the great thing about the area model is that it allows us to use what we know about rectangles area to distribute. So we know the area of a rectangle is just length times width. So if we look at this problem, we can figure out the area by doing 5x times 4. Basically, this is saying we have 4 groups of 5x's, which gives us a total of 20x. So we are saying that 5x times 4 is equal to 20x. Now, as you complete more problems, you'll, especially on the homework, you'll see that these problems are not all set up the same way as the notes. So I am going to kind of be adding things in that I need to make sure you are adding in. So for example, in this next rectangle, we have a height of 4, and then we have lengths of 8c and y. So we divided a big rectangle into 2 smaller pieces. So this would be written as 4 times 8c plus y. That's not a y. So we take the 8c, it goes right there, the y goes right there. We split up the 8c and the y into a rectangle. We split it into 2 pieces. From here, we're just taking the area of each individual rectangle. So for the bigger one, I'm going to do 4 times 8c. So again, that's 4 groups of 8c's. So that gives you a total of 32 c's. Then you repeat that with 4 times y. So that is just going to be 4y. Last but not least, you need to write it as a sum. So 32c plus 4y. Now, remember, you can only add when you have like terms. So for example, in this case, 32 plus 4 is 36. We can't say that this answer is 36cy. Because the c and y are different variables, you can't add them together. You just leave them separate from each other. All right, let's go ahead and test it out. So for this first problem, we're essentially saying c times 4 plus 3. That's what the problem would look like if we were to set it up. So using the area model, I have my 2 rectangles. I split up the 4 and 3. So for the first part, I would do c times 4, which is 4c. For the second part, I would do c times 3, which is 3c. And then I write those as a sum. So now I have 4c plus 3c. Now these two are like terms, so we can go ahead and add them to get 7c. All right, let's go ahead and do the one next to it. So this problem would be 6 times 7m plus n. So you can see I split up the 7m and n into 2 rectangles. So to figure out what it looks like after I distribute, 6 times 7 is 42, so I'm doing 6 times 7m to get 42m, and then 6 times n to get 6n. I need to write that as a sum, so 42m plus 6n is my answer. Again, I can't combine those because they're not like terms. Okay, want you to go ahead, pause the video. You can cross out this bottom left one. We're not going to do that one. But I do want you to go ahead and do the next 3. So think about what it would look like before you set up the area model. So what does that initial distributive property problem look like, and then go ahead and apply the area model. All right, so this first one, if we were to set it up initially, it would look like this, 2 times 7 plus y. So my area model tells me I'm going to do 2 times 7, which is 14, and then 2 times y, which is 2y. And then I write that as a sum, so 2y plus 14. Now, if you wrote 14 plus 2y, that's fine as well. It doesn't matter what order you write it in. Okay, let's try the next one. This one would be 3 times k plus 5j. So using my area model, I have 3 times k, which is 3k. And then 3 times 5j, which is 15j. And then write those as a sum. So I have 3k plus 15j. Okay, last one. I have 8 times x plus y. So this one I'm going to do 8 times x to get 8x. And then this one is 8 times y to get 8y. And then I write them as a sum, 8x plus 8y. So that is using the area model to distribute. We're going to go ahead and do the next step. So go back up to the top of your notes and let's look at side 2. So if on the first page we were using the area model to distribute, this next part we're going to use the area model to do something called factoring. Now factoring is kind of the opposite of distributing, right? Every operation has its opposite. So addition and subtraction are opposites of each other. Multiplication and division are opposites of each other. Factoring and distributive property are opposites of each other. So if we were essentially multiplying to distribute, we're going to be dividing to factor. So what does that look like? Well, in this first problem, we're saying the area of this rectangle is 16y. I know that the length is 8, but I don't know what the height is. That one I'm unsure about. So I'm asking myself, 8 times what will give me 16y? Now, the 16 part, that's easy enough to figure out, right? We know 8 times 2 is 16. But what about the y? So in order to add a y, I need to multiply it by y, so it becomes 8. It becomes 2y. So how would I write my final answer? Well, if my original problem is 16y, my answer is just going to be 8 times 2y. Okay, let's look at the next one. Now this next one, we're starting off with 15x and 6y. So I need to find a number that both 15 and 6 can be divided by. And in doing so, I know I can divide both of those by 3. So that means I'm going to bring 3 over here on the side, because in this way both rectangles are being connected to it. From there, I just divide, right? 15 divided by 3 is 5, but I still need my x, so I make it 5x. 6 divided by 3 is 2, but I still need my y, I'm sorry, so I make it 2y. So if we started with 15x plus 6y, when we factor, we end up with 3 times 5x plus 2y. So you're essentially working backwards in the distributive property problem. All right, so let's move on to the second page and do a few of those problems together. All right, so let's go ahead and factor. So let's start with these. So this first one may start off looking like this. So I have 9 plus 6. Okay, I know that I can divide 3 by both of those numbers. 9 divided by 3 is 3. 6 divided by 3 is 2. So my final answer would just be 3 times 3 plus 2. Notice I'm not actually giving you a final number. I'm not adding them together. I'm just practicing the factoring. Okay, let's try the one next to it. So this one, we're starting off with 4x plus 8. So I know both of them can be divided by 4. 4 divided by 4 is 1. And then I have my x I need to bring down. 8 divided by 4 is 2. So how would I write that? Well, I would bring 4 on the outside. Inside would be 1x plus 2. Okay, let's try this one. This one I have 14m plus 5m. Okay, again, I can see I can pull out the m, and in doing so, when I pull that m out, I'm left with 14 and 5. So my answer would just be m times 14 plus 5. Again, I'm not worried about combining the 14 and the 5, just leaving it as a sum. Okay. Go ahead, pause the video, and try this one on your own. All right, so for this one, we're saying we're dividing by 6. We started off with 18r plus 6s. 18 divided by 6 is 3, and then I bring down my r. 6 divided by 6 is 1, and then bring down my s. So my final answer would be 6 times 3r plus 1s. All right, so for those first 4, you were given what to divide by. Let's work with trying to figure out what actually to divide by. So for this one, I'm starting off with 6x plus 2y. I know I can divide both 6 and 2 by 2. So I'm going to put the 2 over there on the side. 6 divided by 2 is 3, bring down the x. 2 divided by 2 is 1, bring down the y. And then just write it with parentheses. So 2 times 3x plus 1y. Okay, let's try another one. Okay, for this one, I have 30 plus 6y, or 6y plus 30, depending on how you write it. Now this one, I notice I can divide by a few different options. So it really, as long as you're factoring at this point, we're not too concerned with what number you're dividing by. I'm going to go with the bigger one, and in this case, I'm going to say I can divide by 6. So 30 divided by 6 is 5. 6y divided by 6 is 1. Bring down the y. So my final answer is 6 times 5 plus 1y. All right. Now this one, I see they both have an n in common, so that means I can divide by n. So if I'm starting off with 4n plus n, when I divide by n, I'm left with 4, and here, well, what number am I left with? This is technically a 1. Remember, if you don't see a number in front of the variable, you assume there's 1. So that means I would be left with 1. So my final answer would be n times 4 plus 1. All right, we're going to go ahead and cross that bottom left one out. I want you guys to pause the video and try the last 2 on your own. All right, let's take a look. Now this one, I really only have one choice, and that's 3. 15 divided by 3 is 5. Bring down the x. 9 divided by 3 is 3. Bring down the y. So the original problem was 15x plus 9y. So my final answer would be 3 times 5x plus 3y. Now, last but not least, this one has a couple of different choices, so we're going to do both of them. So our original problem is 12y plus 4z. Some of you may recognize, okay, they're both even. I can divide by 2, and you can. That's fine. 12 divided by 2 is 6. Bring down the y. 4 divided by 2 is 2. Bring down the z. So one possible answer is 2 times 6y plus 2z. But there's another possible answer, so I'm going to go in red for this one. I could also divide by 4. And when I divide by 4, 12 divided by 4 is 3. Bring down the y. 4 divided by 4 is 1. Bring down the z. So my other possible answer is 4 times 3y plus 1z. So you can have either answer for those. All right, so on your homework tonight, just remember you're probably going to have to draw your own rectangles or fill in the rectangles, kind of like we did on the first page. And then on the other page, the factoring page, same thing. You're gonna have to fill in your own rectangles or draw your own rectangles, but use these notes to help you. It will make a huge difference. Thanks for watching.